All right. I've noticed some of you going ahead and taking the opportunity to write this content down. I'll go ahead and let you get caught up with that. If you feel those, formula sheets are for your benefit, I would suggest go ahead and reach for them or find them at your earliest convenience. And what I want to do is let you, obviously, there's 4 pages of those flow charts or formula sheets, or what's the best way to explain what it is we're talking about? Is it flow charts? Okay. So of those 4 pages, which one can you definitely eliminate? Which one of those 4 pages can you definitely eliminate?
I think we have 4. We have front and back.
And a front and a back.
Front and back.
We have a front and back and a front and back.
Okay.
On the way bottom one, underneath the arrow, does that say 140?
It says 140, yes. Okay. So you are right. Why are you right? Well, it does, but when you pointed that out, said you can eliminate this one, what's on the front side of that? Nope, the other side that you pointed at. Look at what's in the center. Right. Benzene. There is no benzene up there. So these are aliphatic compounds. These are not aromatics. Because remember, the aromatics are those that result from that of benzene. So to help you in your understanding, okay, what type of compounds are we referring to in these 3? Well, we've been talking about this entire chapter so far. Okay. What did we say was probably the most important, what I want to say, concept to understand when you're looking at these 2? Not just the name, but what's probably the most important. Exactly. So what you want to be doing is looking on your chart somewhere where it's going to say something along the lines of something primary alcohols, something secondary. I think it's oxidization or oxidizing. Yes. That's one. And then maybe right below it, it's got secondary.
And on the back, we have dehydration.
Okay. So we did a little bit of that yesterday. Okay. So when we look at this, your flow charts will tell you that. Which one of these is perhaps more complex? By just looking at your flow charts initially. You are right. Why would that be?
You get 2 products instead of just 1.
Yeah. Oh, yes. There's 2 steps. Yes. Okay. So what that means is, in this case, this has an intermediate step. This one does not. Okay. So is that where you want to go in a progressive order or just, okay? So if we recognize that we've got an alcohol and we've got a secondary alcohol, what does that tell you you're going to do if you're reacting that with an oxidizing agent? It will form something very specific. Because it just has R's on there, don't remember? R is any hydrocarbon attached to maybe another hydrocarbon and hydrogens. But on this side, okay, we're not losing anything. Something very specific happens there. Double bonded what though? Right. Because what happens, we now have formed what then? And that is not written correctly. I do. So of these, actually I'm glad I should have just left this up here, see if we were paying attention. And it sounds like you were, or are. Okay. Can we take away that bond? No, we can't. Can we take away this one? No, because then you're breaking the compound apart. Okay? So since we made an addition here, okay, which one of those bonds is going to disappear then? Yeah, the one on top. Okay? So now what happens with secondary alcohols, they get oxidized into what organic family is this? Nope, not quite. Alketone? Oh, yes, ketones. That's right.
It's on the end, would it be an aldehyde?
It would.
It's a ketone.
That's right.
And how do you label those? So like if it's, so like yesterday we went over to propanol, so that's
Okay.
an aldehyde. So then what would be a ketone? Or wait,
You have to put it in the name or not?
What, that is a ketone? Okay. Well, if you had to name this, what's your parent chain? Because that never changes. Okay. Okay. Now this is where everything changes up from what we've learned so far. If we did this, it's an alkane. If we did this, it's an alkene. You change that A to a Y, then we got a triple bond. And if we did this, we're still not quite right.
would it confuse them?
It would. Now we've got our ketone. We've just got one little subtle thing to put on there. Gesundheit. Yeah. They said a 2, so I said Gesundheit. That's just being kind, that's all, right? Yeah. Okay. Okay. Yes. 2-butanol. That's right. Okay. Well, see, I just want to make sure that our faces aren't broken. How many times have you heard that?
A lot.
A lot. Yeah. Okay. Pretty straightforward, or yes or no. One of the things that hopefully we can help you out here, looking back, even if we just stopped here, how many of you would believe that this would appear that this is simpler than the aromatics? Okay. Maybe this is a little more cut and dry and easier to follow rather than trying to see, well, if we've got phenol here and if we're going to add some chlorine to it, what's going to happen? Of course, then you get two products, and of course, we all remember that because we evaluated you over that. This is maybe, like I said, maybe a little more straightforward.
What chart is easier to read?
This one here.
Or like this stuff, it's easier to read than like what we did in last chapter.
Okay, asked and answered. Now, so we're starting with what compound here? Not just an alcohol, not just secondary alcohol, but it's called what? Okay, a little more specific. 2-butanol gets oxidized to 2-butanone. Yes, you're making a ketone. Secondary alcohols get oxidized into ketones. Okay? Now, when we move forward with that of primary alcohols, it's just a little more complex. Okay? You said there's 2 stages. You are correct when you say that. Okay? One of the things I can't quite remember, I don't think these need a catalyst. This is a dehydration reagent. The reason this is on here is because it matters what temperature these are occurring at. Because if it's a higher temperature, I believe they form ethers. If it's at lower temperatures, they form alkenes. All right. So, what happens in stage 1 with a primary alcohol? What does it tell you that it will form? Okay, so now we've got our 4 carbons on here. Okay, we've got all of our hydrogens, including this one. And then what do we see? How are we going to correctly make this an aldehyde now? Because, yeah, it does form an aldehyde, but how would you know you're forming that? Okay? All right. There is... Okay. It just says stage 2 after that, doesn't it?
It says you get that, and then it adds like K2CR2O7.
Oh, okay. There. Yes, that's true. This is one oxidizing agent. That is another one. Okay? Those both do the same things. Okay? Both of these are very powerful oxidizing agents. Okay? That's all we need to know about that. We could get the book out. We could read about this. There again, what happens is you've got this 2 liters of information that you can hold, and here we're trying to pour a gallon into that 2 liters. Eventually it's just going to overflow. What we want you to know is that with these powerful oxidizing agents, for some reason, one that I really can't explain, this is probably more reactive than that one, just because of the way the molecules are bonded together with one another. If it's on the end, it's probably much, much more reactive. And all it does is this just keeps on going. That's all you need to know.
If you have that, like on a thing, it says that like you have a double bonded oxygen, and you also have,
Oh, maybe that's left over.
well, and then in step 2 you get an acid.
Right. Right. Okay. I just want to make sure we're communicating. Okay.
So, like, how do you end up with that?
Oh, okay. See, you would be correct if you're saying you're getting that alcohol, but notice that's still up there. Okay? So if that double bond is on the end, like what we have now, yes, that is an aldehyde. But what happens is this just continues to react, and when you have a double bonded oxygen and an OH, like Amanda had said, that is an acid now. All we're doing is just saying it just keeps on going.
So you don't have to add any.
No. What's happening is this is still just left over. I think, is that maybe what's throwing you off? It's new. That's probably what's difficult too.
Because like it has that, and it's adding that, and then like you get that.
Right. But what it means... Oh, okay. Because so okay, I found that. Maybe so those of you in the gallery, it's tough to ask questions because this is not in real time. So on page 390, okay, actually, sorry, starts on page 389. Okay, at the very bottom, it's talking about primary alcohols, which is what we have here. Okay, stage 1, simultaneous loss of hydrogens called dehydrogenation from the OH group from the carbon holding the OH produces a carbonyl group. Remember, any carbonyl group is either going to be an acid, a ketone, or an aldehyde. It just means that you have that. Okay. As shown in the next equation, the resulting compound is classified as an aldehyde because it just says NH, or a hydrogen, is attached to the carbonyl carbon. Okay? And that's what it's saying here. You still have that hydrogen attached to that carbonyl carbon. Okay? Stage 2, oxidation of the hydrogen attached to the carbonyl group to the OH converts the carbonyl group to a carboxyl group, or COOH. Okay? In other words, you're losing now the hydrogen. Oxidation with permanganate or dichromate. This is permanganate, this is dichromate. Okay? That's all that, that's all that the author is saying. Okay? Proceeds from the primary alcohol all the way to the carboxylic acid without stopping at the aldehyde stage because these oxidizing agents are too strong. It just means it just keeps on going, okay, until you reach the end. This is just going to keep on going. One way to maybe look at that is if you had really strong acid, hydrofluoric, hydrochloric, any one of those, you put your finger in there, or maybe even hot water is better. The longer you keep your finger in there, the more damage it's going to do. In other words, the damage just keeps on continuing. Okay? That's what it's trying to say here. This oxidizing agent is too strong to stop at that stage. It just keeps on going until it can't go any further, and that's when it reaches an acid. So I don't want to say avoid that, but that's where this information comes from. It just says it's too strong to stop. It just keeps on going. It's just the way it is. If you got a circle, it's just the way it is. Eventually you're going to multiply by what constant to find the circumference? Pi. Yes, 3.14. That's just the way the math works out. I don't know if that helps. Just have to accept that's just the way that this works out. Okay. So when this continues then, what does it say that happens in stage 2 now? So we reached stage 1, and you had already alluded to that back there. This will now form a what in stage 2? It forms an acid, okay? So what that means, okay, think we'll talk about these dehydrations tomorrow. Okay. Kind of ran out of room, and I'm looking at the time here. Okay. So here is what do you think we would call that? Either this count, it's the same thing. You correctly said this was 2-butanone This, however, still 4 carbons. But how does the suffix change? Al for an aldehyde. And we don't need to say where that double bonded oxygen is like we do up here, because it's always on the end. I mean, you can, but when you were talking about acids last year, how many times did you ever do that? Never. You could, but it just kind of looks silly. So that's why you would not write 1-butanol. Okay. So now this proceeds, keeps on going. How do we make that into an acid now? You still have a carbonyl carbon, which means we still have this, that double bond. But how do we make that into an acid now? What does it tell you on? Yep, we need an OH. All right. Okay. That is butanoic acid. I'll even go get some butanoic acid if you want. No takers? Oh, someone's got to be curious. Going once, going twice. Okay, that's fine. All right. One thing I do want to go over quickly is we never did finish. I can't remember what the exact structure was. I want to say it looks something like that. Okay? First of all, does this look like anything we've talked about before? You're shaking your head no. You would be correct when you say that, okay? So remember, if we say X marks the spot with this, what type of alcohol would we possibly be talking about? It is a tertiary alcohol because this carbon is attached to 3 others, okay? Just like this one was only attached to 1, and then when we had this one up here, if that was an OH, it was attached to 2. Okay? Last thing we want to talk about is this is probably another one of them that's an exception to the rule. We're not starting down here because this is actually branching off of the parent chain. Okay? Okay? Any takers? I'll see if there's some examples on or in the book. Actually, we're getting close to 5 after 9, so we will start with that tomorrow. We'll catch up to you next time.